Hey kiddos, today we're going to talk about reference angles. This is lesson 2.4 in your composition book. If you do not have the printed notes and would like a copy of the printed notes, you may print those from your Canvas page. Otherwise, you can just write them in your composition notebook. All right, what is a reference angle? A reference angle is an acute angle made with the x-axis. And out of everything in this statement, probably the most important thing, it's all important, but we are always going to make this angle with the x-axis. That means if our reference angle is angle theta, that theta will be between 0 degrees and 90 degrees, or theta will be between 0 and pi over 2 radians. If you will open your notes to the inside, we're going to do the inside of your notes first, and then we'll come back to the examples. So if we look at quadrant 1 and we think about the dynamics of quadrant 1, in quadrant 1, this is 0, and if we're in radians, we are at pi over 2, or we are at 90 degrees, depending on which unit we are doing. This angle here is your reference angle. And by nature of the location of angles in quadrant 1, these angles are already positive and they are already made with the x-axis. So if you have an angle in quadrant 1, the measure of the angle in standard position is also the measure of the reference angle. All right, moving on to quadrant. If we think about the reference angle in quadrant 2, the reference angle in quadrant 2, if you make an angle that's made with the positive x-axis in quadrant 2, it is going to be this angle right here. So, for instance, if I give you an angle measure of 129 degrees, and that's the angle in standard position, that basically means that the angle from the positive x-axis around to your terminal side was 129 degrees. Since that angle is bigger than 90 degrees and it's not an acute angle, that is not your reference angle. In order to find the remaining part of the angle, we are going to take 180 degrees and subtract 129. So I have a reference angle of 51 degrees, which meets the conditions that theta is between 0 and 90 degrees. If I look at quadrant 3, in quadrant 3, my reference angle is going to be this angle right here. It's going to be an acute angle made with the positive x-axis. So if I give you an angle, and this time we'll do one in radians, if I give you an angle in standard position, and let's say this time that our angle is going to be 19 pi over 16. And I say, hey, we need to find a reference angle. We need an acute angle made with the positive x-axis. If I think about this axis here, and I think about how many radians are in this axis, there are pi radians in this axis. So when I start in standard position and I go around from here to here, I've traveled pi radians. I really need to know how much further I'm traveling right here. So I'm going to take 19 pi over 16, and I'm going to subtract out pi. As we've been doing in previous sections, we're going to multiply by the wacky form of 1, so we're going to find ourselves a common denominator of 16. 19 pi minus 16 pi is going to be 3 pi over 16, and 3 pi over 16 meets the condition of a positive acute angle between 0 and pi over 2. That means this angle here would be 3 pi over 16. In quadrant 4, oops, copied and pasted the wrong picture, so let's adjust our picture. So in quadrant 4, our reference angle is going to be right here. And if I think about how this is going to work, if I give you guys an angle in standard position, and we start here and we go all the way around here, and this time we'll do some decimal radians. So let's say that this angle is 5.58 radians from the positive x-axis around to the terminal side. Again, think of the dynamics of the circle. this angle is made right here with the x-axis, and there are 2 pi or 6.28 radians in this axis. So if I travel around, I start here and I'm going around my circle, pi, 1.5 pi. I just fall short of 2 pi. So I'm going to take 6.28. I'm going to subtract my angle measure of 5.58, and I'm going to stack my fractions because I do not have a calculator. So I'm going to subtract, and 12 minus 5 is 7. So I have an angle measure, a reference angle measure of 0.7, which meets a condition that it's acute because theta is between 0 and 1.57. Now, if you flip back to the examples on your previous page, it says, sketch the reference angle and find its measure. So one important thing to remember as you go through this entire chapter, not just reference angles, but remember that whatever units we start with, that's what we're going to stick with through the entire problem. The biggest thing about this is picture your angles. So if I picture an angle that's negative 161 degrees, that angle is going to terminate somewhere in quadrant 3. So if I think of the location of my reference angle, it's going to be this angle right here. This angle was negative 161, not 67, 161 degrees. So if I think about what is the distance from here to here, I'm just going to take 180 and I'm going to subtract 161 and I'm going to get 19 degrees. So this angle right here is your reference angle and it's 19 degrees. And remember, by definition, reference angles are always positive. If we think about 5.29 and we start at our initial side and I go around 5.29, I'm at 1.57, 3.14, 4.71. So over here somewhere is 5.29. This means my reference angle is a little bit of an angle that I have left right here. So I think about this axis right here, and I know that there are 6.28 in the axis that angle touches. So I am going to take 6.28 and I'm going to subtract 5.29. And if my math serves me correctly, I'm going to get 0.99 radians, which meets the condition that theta is between 0 and 1.57, making it a positive acute angle. All right, moving on to example C. If you think of 5 pi over 6, and we have to determine the quadrant that angle is in, 5 pi over 6 is less than 1, 5/6 is less than 1, so I know it's in quadrant 1 or 2. It's bigger than 1/2, so 5 pi over 6 is going to be over here in quadrant number 2. So the question is, if I rotate 5 pi over 6, how many radians are left until I hit this axis, which contains pi radians? So because I fell just short of that angle, I'm going to take pi, and I'm going to subtract out the standard position angle. Again, our favorite thing, wacky form of 1, let's find a common denominator. So my common denominator is 6. So now I have 6 pi over 6 minus 5 pi over 6, which gives me an answer of pi over 6. And that meets my condition that theta is acute because pi over 6 is between 0 and pi halves. I want you to take a minute and hit pause, and I want you to try example D on your own. All right, welcome back. If you did example D, I'm going to go through this pretty quickly. So 11 pi over 9 is really 1 and 2/9 pi. So if I come over here, then 1 and 2/9, 1 pi puts us in quadrant 3. 2/9 is actually less than a half, so it's going to be somewhere over here in quadrant 3. If I think about the location of my reference angle is right here. Because I overshot the axis that contains pi, I'm going to take my reference angle, which is 11 pi over 9, and I'm going to subtract out all of this excess right here. So I'm going to take 11 pi over 9, and I'm going to subtract out pi. Finding a common denominator, my common denominator is 9. So 11 pi over 9 minus 9 pi over 9 gives me 2 pi over 9. Again, reference angles are always positive, so that theta value is between 0 and pi halves and means that it is a reference angle. These questions can also be asked in reverse. So for these examples, they're giving us the reference angle and they'd like the angle in standard position. Again, I think the easiest thing to do is to visualize what is happening. Here, they tell you that we are in quadrant 2 and that we have a reference angle that is 3 pi over 7. This time, however, they are wanting us to find this part of the angle here. So what was the angle if we would have started at the positive x-axis? Since this axis here contains pi, I'm going to go ahead and subtract the two angles because they are supplementary angles. So if I take pi and I subtract 3 pi over 7, I need to find my common denominator. And yes, I do want you guys doing this process because it will help later on in Unit 4 when we are using trig identities. 7 pi over 7 minus 3 pi over 7 is 4 pi over 7, again, meeting the condition of a reference angle where theta is between 0 and pi over 2. All right, 1.26 is an acute angle. It is in quadrant 4, so if I draw an angle that's 1.26 radians in quadrant 4, this angle here is 1.26 radians. In quadrant 4, your quadrant 4 angles touch this x-axis here, which contains 6.28 radians to be exact. So you need to think, all right, if I start here and I travel all the way around here, how far have I rotated? So I'm going to take my 6.28. I'm going to subtract out the 1.26 to determine what's left. Do some quick subtraction. And I get an initial angle in standard position of 5.02 radians. That's all I have for you today. If you have any questions, write them down, throw them in the basket on your way into class, and we will talk about them tomorrow. Have a great evening, and we'll see you tomorrow. Bye.